Welcome to qnawire.
For this problem, we're going to be using Stokes Theorem, and Stokes Theorem is an incredibly useful way of calculating double integrals. And what it states is that the double integral of the curl of f dot ds is equal to the integral, this is the c integral of f dot dr. And the c refers to the fact that this is the boundary of the surface. So we know that the boundary of the surface is the circle x squared plus y squared equals 1, but it'll be easiest for us to parametrize this. So that'll be that r of t is equal to the vector cosine t sine t 0. And then we have to find dr as we see. So dr will be negative sine t cosine t 0. Now with that in mind, we see that f of xyz is x squared sine z plus y squared xy. So if we want to parametrize that again, so this is going to be f of r of t. This is going to be just plugging in cosine of t for x values, sine of t for y values, and 0 for z values. So what we'll end up getting is 0 sine squared t cosine t sine t. That's our f of r of t. So now we can combine these elements right here. We have our f and we have our dr. When we take the dot product of these, what we'll end up getting, and keep in mind the surface, the boundary is going to be 0 to 2 pi. So what we'll end up getting out of this is the zeros will cancel this, the sine squared and the cosine t will multiply, but then these two will cancel right here. So what we're ultimately left with is sine squared t cosine t dt. So this is the integral that we have here, and we can use the substitution method to determine what we'll do here. But ultimately, what we'll do is it will change the order of integration if we try to do substitution, and what we'll end up having is the bounds of integration being 0 to 0 of u squared du, and that will obviously be 0. So as a result, we see that by Stokes' theorem, the double integral of the curl of f dot ds is equal to 0.